Greetings, this is Artie from Artifact Electronics. In today's episode we'll be looking at a Sony PlayStation 2 gaming console. This console was released in October of 2000. It was a follow-up to Sony's PlayStation 1, retailed at $299. Over its lifetime it sold 150 million copies. There were about or almost 4,000 different games sold for this console, and the total number of games sold is set to be 1.5 billion. Now that makes a neat number because this implies that for every console they sold 10 games. And that was financially very important because traditionally video console manufacturers don't make a lot of money, if any, on sales of the console hardware itself. I don't know what the numbers were on the PS2, but rumor has it that on the Microsoft Xbox they were actually losing about $100 per Xbox sale. And that brings us to the point as so how did they make money, and that is the games. These consoles were security locked. You couldn't just write a game, burn CDs and sell it, but rather Sony had to manufacture these games for you, and that made it very easy for them to collect royalties. They wouldn't just charge you for manufacturing the media, the DVD, but rather charge you for their licensing fee right there. And games were much more profitable than the hardware. And the idea was generally that after selling 3 to 5 games per console, they would be in the green, and everything after that was gravy. Well, with the 1.5 billion games sold, you do the math and figure out how financially successful this console was. Now, the figure of having 10 games sold per console is a little bit skewed because one of the problems the PS2 had was that the DVD drive would crap out on you. And there were class action lawsuits, and Sony finally agreed to fix these and give you a coupon to buy more games. But for a true gamer, say the weekend comes and they want to play their favorite game, and Friday night the DVD drive craps out on them. What are they going to do? Wait for 2 weeks to send it back and get the drive fixed and then play? No, a lot of people went out and bought a new PlayStation so to be able to play their games right there and then. So this kind of changes the figure that even though 150 million of them were sold, many of the users actually owned multiple copies of the console, and thus the average number of games bought per user is probably closer to between 20 and 30 games. Nonetheless, it didn't matter who bought the games. There were still a lot of games bought, making this a very successful gaming console. The internals, it uses something called the Emotion Engine GPU, which made it compatible with almost all PlayStation 1 games. And the performance of it, taking lighting, physics, and AI into account, was between 3 and 16 million polygons per second. The resolution, which I don't know exactly, is kind of rough compared to today's standards, but for the time, it was the actual console to have. And 150 million transactions were made to buy one of these things. Now, if you've seen my previous episode, in that episode I had bought an Xbox that wasn't working and got it back to working condition. So my interest in my old collection of game consoles awakened yet again, and I've owned a PS2 since it first came out. I found the PS2 but it did have the dreaded bad DVD drive. Now, I don't remember this. I played with it for a few years, and then the kids took it over and played Guitar Hero on it and packed it away. But I guess at one point in time, the drive quit on it. So I packed it away again because I didn't really feel like dealing with a DVD drive. But a few days later, of course, having the PS2 on my mind, I found one at a pawn shop. And the one I found at the pawn shop came with a controller, all the cables, and better than that was, at the pawn shop I was able to plug it in and test it, and it worked. So for the total sum of probably about, I don't remember, it was like $15 or $16, I bought it. And the main reason I did buy it, of course, was not only did it come with all the stuff, but it also came with the 8 meg memory card, which there's not that many of them. I mean, there's a lot of them around, obviously, with 150 million units sold, but they're not as common as controllers or the console itself. So it was a good deal. It booted up, as you can see, it plays. But there was something wrong with it. I mean, I played pinball games, I played some other games, and something just didn't feel right. And at first I couldn't tell what the problem was. But after a few days, I finally figured out what ailed it. And the controllers that were made for this were called the DualShock controllers. And the reason they were called that was they gave you a rumble function. And the rumble function is that it had two motors, one here and one here, with eccentric weights on the shafts. And when those rotated, it rumbled the controller and gave you tactile feedback. Long and the short of it was, the rumble did not work. I mean, on pinball, it's probably not that important, even though it does. It's a good feeling when you feel a slight rumble whenever you're hitting something on the table. But other games, like Quake, where you're shooting other people and people are shooting you and stuff like that, the feedback you expected to get that feedback, and the games felt hollow without that. So that was the problem with this particular PS2, and I did some research on it, and let's talk about the theory of how the rumble works. At this point you may ask, why am I already jumping the gun and fault isolating it to the console rather than the controller? But the answer to that is I have another 3 controllers for a total of 4, and in none of them did the shaker motor work. So it's still statistically possible that our 4 of them are bad, but that's kind of a remote possibility, so we're going to assume that it is a console that's at fault. Now, I gathered some information online what this whole thing is supposed to look like, and on the left of the dividing line are the components contained in the console, and on the right in the controller itself. So the way this works is we have a supply of approximately 12 volts fused and then running through an 8-volt regulator, and that is tied to one end of the shaker motor winding, and the other end of it is tied to a MOSFET that is grounded. And a logic signal will, when you use a logic signal to turn on the MOSFET, it completes the circuit by grounding the other end of the motor, and the motor starts to run. Simple, straightforward. I'm not sure if this is a MOSFET or it's a bipolar or what all of this is. As I said, this is approximate, but this should give you a pretty good idea of how this is supposed to work. So fault isolating this, doesn't require a PhD here. We're either missing the 8 volts over here, which means the fuse is blown, or the regulator's gone bad, or the driver, the control signal over here, which is most likely buffered, is is getting lost, or even more likely than that is that the MOSFET blew and it just doesn't work. I mean, it's got to be one of those things, but during my research I found out that one of the most common things that happens is probably the most obvious thing you would see in here, and that is that this fuse blows. It's fused at 700 mils, and under normal circumstances, things, you would think that the 700 mils are enough to run it, but there is a motor coming out the other end of it, and motors are known to do strange things once in a while. Whatever the reason is, I'm not going to spend a whole lot of time on that, but this is a non-resettable fuse, so we're going to check that. If that one's good, we're going to see if we can see 8 volts on here. And then basically, if all of that fails, then probably put a scope on the ground line of this thing, which means when the MOSFET's off, it should show about 8 volts over here, and then when it turns on, it should drop to ground. So those are the things we're going to test. And one thing I'm going to say right up front is the way the PS2 is put together with all the shielding and stuff inside, it makes it a bit difficult to test these things. I mean, it's easy to test in the controller, but in the PS2 it's difficult to test because you have to remove all the shields and you end up with this spidery concoction with AC plugged in, and one wrong move and you blow up the whole thing. So I hope that I can actually isolate the defective component by simple in-circuit measurements rather than having to power this thing up with it in pieces. Well, let's take her apart. Here's the unit, here's the bottom of the unit, and here's the rear of the unit. And the top part of the case is held in place by 8 screws. And thankfully the screws are covered by these covers that come out and are held in place by friction, so you don't have to worry about wearing out the adhesive that is holding these in place, and put them back later on and they kind of stay in place. So let's just, oh, that's great, that thing flew off. It's going to take me a few days to find that again, but we just continue on our merry way. There's 2 kinds of inserts here. The 4 at the corners actually have rubber on the bottom, and the other ones are just plain plastic. Boy, these like to fly. And once we have all of the covers taken out, we simply go in and remove the screws, keeping in mind that the 4 screws on the left side in the picture are the long ones, and the 4 screws on the right side in the picture are short ones. And that shouldn't be too hard to remember. So I'll go ahead and remove all of the screws, and we'll see what reveals itself. Having removed all of the bottom screws and set this back right side up will allow us to lift off the top of the case. We'll lift the back of it and pull it forward, and then very gently lift it off. And the reason we need to gently lift it off is so we don't disconnect. Fortunately, this came out of a connector, the part that connects the front buttons. So be careful, the connector's buried in there somewhere, but since I'm going to have to disassemble it, it's not the end of the world, but open it carefully, and so that you don't do the same thing I just did. The button assembly is also held in place by friction, so we can go in here and remove that assembly and set aside the top cover. So now we can see a bunch of heat sinks and the DVD drive unit, and let's go ahead and take those out now. But first we need to take off the bottom cover, and that is held in place by 4 screws. You can see 2 of them here and here, and also, and get that into view, there's a screw here between the fan and the AC plug, and another screw at the end holding this rear cover in place. So what we'll do is remove those screws. Yeah, now this is the connector assembly for the controllers and memory cards. Be careful with it. This also has a ribbon cable connecting it to the board. And now it gets a little bit complicated because there's another screw hidden underneath. I think it's underneath the AC plug, if I remember. And yes, I remembered correctly. It is right here. So if we remove that one, we should be able to remove the bottom cover. And let's see if that is true. It's being obstinate as expected. And we literally have liftoff. We can put away that part, the lower part, and now we have access to the innards. But first we need to, as mentioned before, remove the drive itself. To remove the drive, we have to remove 4 screws holding the cover of the drive that has the part in it that holds the DVD onto the spindle. And there's several connectors. And yes, everything goes into this magnetic screw holder. One of the greatest inventions ever. Because even if you drop the whole damn thing on the floor, the magnet is so strong, it still holds everything in place. And there's a cover. Oh, I didn't even remove the DVD, or actually this is a CD. And it's this blue color with these weird wear marks on it, but this was part of the Sony security procedure, so you couldn't put your own stuff on there. Now, the drive is still held down by this assembly, which holds the fan. So let's see if we can lift this without ripping out the wires that hold the fan in place. And we can. The drive has additional tabs, so we need to bend the tabs to be able to lift the drive. Now the drive is free, but it is connected in several places. First, what we'll do is we will remove the connector going to the head, and I believe that no, it does not pull out, it's actually held in place. So what we're going to do is, there's some connectors on the side, you can see over there. They don't have locking tabs, but they have little extender tabs over here that you can just use to pull out that connector. Here. Having a hard time there grabbing that one. And that one. And there's still something not letting it flip over. Oh, there is yet another connector over here. That one I'm just going to grab, and does that. Oh, that connector, that one is already disconnected. It just got lodged in there. So I have to carefully get that one out. I mean, nothing can be easy, right? What is happening here? Oh, I think the pull tab on it got stuck inside somewhere. Let's see, let me give you a better view of, instead of obscuring everything. Yeah, it's finally got out the obstinate connector here. This pull tab kept getting stuck. And the last connector is coming from the diode assembly, the head. And the way I found the easiest way to disconnect it is to remember one side of the rail lift out the whole thing, lift the rail out, lift out the whole thing, and that gives you easy access to the catches that are holding that wire in place. So you can go ahead, release the catches, pull out the wire, and I guess we can set the head and the rail aside. And no, I'm not going to throw the head into the magnetic bin. But we now finally have the drive coming out with nothing ripped off. I didn't manually move the tray forward because I didn't want to plug it in yet, but now we can set the drive aside. As I was jiggling things around, this connector also came out, which is the assembly for the controls and the memory card. Well, we'll deal with all of that later and continue on getting these shields off. So to continue, we're going to get the power supply out, held in place by 4 screws. And remove this cover here that has some space for a hard disk expansion in here, which I don't have. But it is said that there are certain games that require a hard disk to be in there. And if I ever come across one, we'll have a look at it. But for now, we're taking off the power supply board. Now the power supply board plugs into the motherboard over here, and it also has the AC plug coming into it. And there's your power supply. I've already looked at this, and there is the 8-volt regulator. There's no 8-volt regulation on the main power supply board, so it's got to be happening somewhere else. So we set this aside, take the hard drive cage out, and now finally I think we can go and take out the shields. But there is one more thing. There's an insulator pad here, and that needs to be removed. And we'll put that over here on top of the power supply so we don't forget to put that back. And looks like I also ripped off the fan plug, but the terminals, you can hardly see it, but the terminals are still there. So I'm probably going to be able to solder that back onto the board. The connector is in here. So yeah, that's it's the second one I ripped out, so be careful. And we'll put that aside. So to remove the two shields, we have 7 silver screws like this, and those come out of the locations here, 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 and then these 4. And additionally, there are 2 copper colored screws, and those come out of here and here, holding this hard drive connector in place. And once you got those out, the shield lifts off. That's the top, and you can also remove the bottom of the shield, which looks like there's a bit of dust on the heat sinks. So use some compressed air, clean out things, and then we'll have a look and see if we can find the components I showed you in the diagram earlier on. I cleaned off the back of the boards, back of this board, and there's also a battery in here, which is most likely the holding the real-time clock. And if we have a look at this, and we can get a stable reading, there's still about 3 volts on this, and the real-time clock doesn't use that much, so this battery is still good, and I'm going to leave it in here. Here's the other side of the circuit board. I've identified the 8-volt regulator over here, and after poking around a lot, I've identified PS7 over here, which is pointing at this fuse, if you can see it. And it's extremely small fuse, but it's definitely connected to the input of the regulator. So let's set the meter to continuity and have a look and see if that is our culprit. So going to make sure I'm measuring the right thing here, here's one end of the fuse, and that is connected to the regulator. Here's the other end of the fuse, which is connected to the 12 or the approximate 12 volt supply, and measuring the fuse, we get nothing. So I guess this suffers from the common problem of the fuse supplying that eventually supplies the 8 volts to the shaker motors. This fuse is gone and needs to be replaced. While we're looking at this, there is also right next to it over here, let me see, where did that go to? Oh, it's right here. This is where the fan connector got ripped off. So I'm going to have to clean this up and see if I can solder the fan connector in here and try to figure out what kind of a fuse I have and where to put it, because the shield is actually really low. It actually touches this chip, provides cooling for this chip over here. So there's not a whole lot of room, and I'm going to have to figure out where to physically place a new fuse for this. So here's the result. It's been a little while because the original fuse over here was really small, and I didn't have a replacement for it. Wait, I think I just found the fuse. Huh, there it is. You can't even see that. Well, there it is. It came off. It is dead. But I thought, yeah, I'll outsmart you. I'll open up my old PS2 and take the fuse off of that. And wouldn't you know it, I opened up the thing, and the fuse on my old PS2 was also gone. So I didn't have a whole lot of choice. I did go through my parts bin, and what I did have is I had a 750 mil fuse, so it's a little bit over spec, but at this point I don't really have another choice because well, anyway, this is what I had right here. It's a 750 mil fuse, and it is ridiculously large, but it is connected directly to the primary input on the regulator and to the output, and no, the supply, the 12 volt supply here, and the input to the regulator. I've also put back in the fan connector. I soldered that in, and there's one support on this side that I was able to solder in. The support on the other side had been broken off, but this looks all to be good. It is a close fit with the shield, but I made sure that it is not preventing any contact, any heatsink contact with any of these parts that may be using the shield as a heatsink. So we're actually good there. It just makes it. And once the screws are in holding the two shields together, that'll pull everything closer together and make sure that we have a good fit. So with all of that in place, let us go ahead and start reassembling it. The shields are back on again, and I did make sure that we are not suffering from any shorts or anything like that. I could kind of observe the connections here of the fuse, looking in from here to make sure, again, it wasn't shorting against anything, and that it wasn't keeping this part of the shield up too high to prevent contact on this end with chips, with the top of chips, and everything seems to be in order. It's a bit of a tight fit over here, but I now have the best heat sunk fuse ever used, because that fuse isn't going to be able to warm up. Not that it makes a difference, but whatever. It's under here, and this thing isn't bulging, so. And actually you can, through this hole, this is it. This is the fuse. So, you know, these holes are open, but this one's blocked because of the fuse. So, let's go on the long road of putting the drive back, putting all the connections back, and see what we broke along the way or what we fixed. Don't make the annoying mistake I made, and that is plug in the fan connector that I just resoldered over here before putting on the insulating sheet that goes under the power supply, because if you forget that and you put everything back together, there's no way you can connect the fan. So fan first, then the insulating sheet, and then continue reassembly. So here's a little progress shot. I'm at the point where I reinserted the connector for the DVD head over here, so the head assembly is going to go back in, and we're getting really close to start testing this unit. I put it back together mostly. I've left off the top cover for the DVD caddy and of course the top cover for the whole game, and the reason I did that is sometimes the loading mechanism gets confused when you disassemble it and put it back, and the motion that raises the spindle and pulls the caddy in and out get out of sync and it gets stuck. So one of the first things to test is if the caddy opens and closes correctly, and it does. So that part's good. Now what we need to do is see if we plugged everything in correctly, and to see if it still loads a DVD. I'm going to use Quake 3 Revolution, and I need to put the little spindle magnet on top of this, which I've removed from the tray cover. If you don't put that on, the DVD will fly off in a most unwelcome fashion. But anyway, let's see what happens. We're resetting the machine, and looks like the drive is starting to spin, and if it speeds up, that usually means it recognized the DVD. And yeah, when it gets to this point, that usually means it passed security and is able to read the DVD. So it looks like we plugged most everything in correctly. Now we get to the point of trying to test and see if the shaker motors are working. While loading the game, let's have a quick look at the shaker motors from another controller. This controller actually caused me a lot of amusement or non-amusement because I could not get the buttons to work on it. And finally, after trying out a whole lot of things, I looked at the connector, and it's kind of hard to see, but if you look at the rightmost compartment, you can kind of, well, you can't really see it, or maybe you can, but one of the pins on the rightmost compartment in here is broken off. I don't know how they did that, but with that pin gone, obviously things weren't working well. I'm not sure of the exact function of that pin, but yeah, it took me a while to figure out that the reason it wasn't working was a connectivity problem. But anyway, so I have a parts controller here. You will see the shaker motors over here, and let's continue this load here. And you can see the eccentric weights mounted at the end of it. These are half cylinders. This one is only a single slice, or half a pizza, and this one's like four half pizzas stacked on top of each other. The heavier this part is, the more it will cause. The more this will cause the controller to shake. So we have basically, they can be off. They can be on light mode, which only moves this. They can be on medium mode, which only moves this, and then on heavy mode, which moves both of them at the same time. Some games offer that option, but most games pretty much go with on or off and make internal decisions on which one to use for what function. In the Quake game, the way it works is when you fire your own weapon, this one turns, and when you get hit by somebody else's bullets, then this one turns, the heavy one turns. So you get a light response when you shoot and a heavy response when somebody else shoots at you. Alright, so I've set up the game, and let's see if we can make this visible to you. Let's see, so when I fire my own weapon, this one should spin. Let's see, is that visible? Yes. You can see that when I'm shooting my weapon, the one on the right is spinning. Now, I can either be shot by somebody else and see if the other side spins, or I can stand really close to the wall, and when I shoot, they should both spin, because one indicates I've just made a shot, and the other one indicates that since I was so close to the wall, I'm blowing myself up. And if we look at the left one, yep, you can see the left one spin. Oh, I'm too far away from the wall, so I'll get close to the wall again, and we'll see both of them spin. Well, not if you're out of ammo. So I need to find, well, either somebody needs to come and shoot me, or I need to find some ammo for the rocket launcher. Boom, there. I felt that. Shoot me. All right. I hope you saw that. So this one's working too. And there he is. Shoot me. Yes, there you go. And of course, when I shoot, the right one is basically working. And now the other guy's coming and shooting me. And so there you go. Even if I put it on the table and I wait for someone to come shoot me, the joystick should start, the controller should start dancing on the table. Alright, go ahead. There you go. So, as you can see, it looks like the problem was fixed and was essentially the fuse gone on the 8-volt line. So the logic works, everything works, but there was no supply voltage to make the motors run. Alright, final assembly completed. One last test is I put a Simpsons game in there, see if that behaves itself. Anyway, my standard disclaimer, this is simply a recounting of what I did to fix my own machine, and by no ways a 100% guide to how to fix these things. So I'm sure you can get lots of hints from here on how to fix yours, but if you break things, if you break ribbon cables or drop things or do harm to yourself, don't hold me responsible, because you're on your own when trying to fix one of these. If you watched it for informative purposes, then use the information you gathered with common sense. One thing to really watch out for is when you remove the bottom half of the case, the power supply board is down here, and if this thing's plugged into AC, there is live AC there. It's very common once you're working with the unit to pick it up when the case is off like this, and then try to turn it around or whatever. And what will happen is if your finger get underneath you on the power supply board, there's a high probability you will touch AC voltage there and it will bite you, which is unpleasant, as most of you probably know. So unplug it. Once the case comes off, unplug it and don't plug it back in again till the case is back on. Let's see, other than that, the only thing I should mention is I was kind of lucky. I replaced the fuse and it seemed to work afterwards. What may happen is if there's another fault, we don't know what the actual fault was that caused the fuse to blow. But if you put in a new fuse and it blows again, most likely the regulator has shorted. and you're going to have to go in there and replace the fuse again and replace the regulator also. Now the regulator, it's pretty easy to measure. The center pin or the tab is ground. If either the leftmost or rightmost pin are shorted to ground, then you got a bad regulator over there. And those regulators are pretty commonly available. But other than that, you know, things work. If you liked what you saw, then let your mouse do the talking on the like button. And make sure to subscribe. I appreciate each and every one of you watching this, but it would be really nice if you told your friends, so we get a few more people watching this and make this into more of a success than it already is. Well, thanks, and we'll see you later.